the next question we have is also an easy problem, provided you use all the concepts properly. We need to show that a real number x will satisfy the given equation if a condition is given, which is a square plus b square equals 1. We need to prove that the x which is satisfying this given equation is real. So what we do is, we try to simplify this equation. This becomes 1 plus iota x upon 1 minus iota x is equal to 1 upon a minus iota b. On applying componendo dividendo, this componendo dividendo, when applied on this, we get 1 upon iota x is equal to 1 plus a minus iota b upon 1 minus a plus iota b. So iota x will become 1 minus a plus iota b upon 1 plus a minus iota b. On rationalizing the denominator, that is by multiplying both the numerator and denominator by 1 plus a plus iota b, we'll get, this is 1 plus iota b minus a, 1 plus iota b plus a. So this becomes a square minus b square, that is 1 plus iota b whole square minus a square. Here we are considering 1 plus iota b, these two terms are being clubbed together, minus a, and 1 plus iota b clubbed together plus a. So this becomes a term square, capital A square minus capital B square. Capital A was 1 plus iota b and capital B was small a, and in the denominator we get again capital A minus capital B into capital A plus capital B, that is capital A square minus capital B square, that is 1 plus a whole square minus iota square beta square. Iota square is already minus 1, so this becomes plus b square. So this becomes 1 minus plus iota square b square, which is minus b square, plus 2 iota b minus a square upon 1 plus a whole square plus b square. This becomes 1 minus a square plus b square plus 2 iota b upon 1 plus a whole square plus b square. Now we know that a square plus b square is equal to 1. So this gets cancelled out with this one. So what we get is, the value of iota x is equal to 2 iota b upon 1 plus a whole square plus b square. This iota and iota gets cancelled. So we get x equals 2b upon 1 plus a whole square plus b square. And since we know that a and b are both real, so the value of x in terms of a and b which we have obtained is also real. Hence we have proved that a real x is satisfying the given equation. Now there is an alternate way to solve this question. We had 1 minus iota x upon 1 plus iota x equals a minus iota b. This is the alternate solution. Now what we do is, we take bar both sides, is equal to a minus iota b. Now let us take x to be real. So, and we know that the property of a upon b whole bar is equal to a bar upon b bar, and the property of ab bar is equal to a bar into b bar. So on taking the bar, the numerator becomes 1, minus iota becomes plus iota, x bar is already equal to x since x is real. So this becomes 1 plus iota x upon this plus iota becomes minus iota times x. This a is real, so a minus iota becomes plus iota, and b is b because b is also real. So we get 1 plus iota x upon 1 minus iota x is equal to a plus iota b. If this is the first equation, this is the second equation. If we multiply the first and the second equations, what we get is 1 minus iota x and 1 minus iota x gets cancelled. 1 plus iota x and 1 plus iota x also gets cancelled, and we get 1 in the left hand side. And this becomes a minus iota b into a plus iota b, which is equal to a square minus iota square b square, which is plus b square, which is true, since it is given in the question that a square plus b square is equal to 1. Hence the assumption which we took, that x is real, is also correct, and hence we have proved that a real x is satisfying the given equation. In this question, we adopted two different methods to solve the problem. You may like any one of the methods to solve that a real value of x is satisfying the given equation.